The Eurolabs project offers transnational access to more than 40 European research infrastructures and brings together the three scientific communities of nuclear physics, detectors, and accelerators for particle physics. The transnational access activity supports small teams to carry out experiments and tests in facilities. Among these, there is the TANDEM facility at IFIN-HH in Romania.
My name is Constantin Mihai, Senior Scientist in IFIN-HH. I am in charge of the activities at the 9 MV TANDEM Accelerator and Facility Coordinator within the Eurolabs project.
The 9 MV TANDEM Accelerator is the primary tool to investigate the structure of atomic nuclei, used by the Nuclear Physics Department at IFIN-HH. The charged particles are accelerated by a high-voltage static field. The charged particles begin their journey in one of the two available ion sources. The generated negative ions span the entire mass range, from the lightest protons and alpha particles all the way up to heavy ions like lead or gold. The ions enter the accelerator tank, whose terminal can be charged up to a positive potential of 9 MV. Under this enormous potential difference, the negative ions are attracted by the positive terminal and greatly accelerated. Once they reach the terminal, the ions are stripped of negative charges. The now positively charged ions are repelled by the positive terminal and enter the second stage of acceleration, hence the TANDEM designation for this accelerator. Once accelerated, the ion beam is well collimated using a complex system of lenses and magnets while transported towards one of the several experimental lines. Each beamline is equipped with detection systems. The 1 MV Tandetron is a state-of-the-art equipment that plays the key role in the AMS studies. Carbon-14 dating is by far the most common application, with more than 80% of the beam time allocated. Besides radiocarbon, other isotopes like beryllium-10, aluminum-26, iodine-129 and, more recently, actinides were successfully measured within geological and environmental studies. The 3 MV Tandetron accelerator is mainly dedicated to applied research. The accelerator system uses an solid-state parallel-fed Cockcroft-Walton power supply for generating high-voltage and an ion beam injector comprising 2 negative ion sources. A unique feature is the sodium charge exchange canal, used to obtain high-intensity alpha beams of at least 3 microampere. The 3 MV Tandetron has 3 experimental beamlines, each with a reaction chamber containing all the necessary equipment. IBA studies, charged particle detectors for Rutherford backscattering spectrometry and elastic recoil analysis, SDD detectors for X-rays used in particle-induced X-ray spectroscopy, semiconductor detectors for gamma radiation and Marcus ionization chamber, used in the dosimetry required for radiobiology experiments. Last but not least, IFIN-HH operates the high-power laser system of ELI-NP, currently the most powerful lasers available worldwide. ELI-NP has been included in the European Strategy Forum on Research Infrastructures as key facilities essential for the future of the European science. The 2 laser arms are capable of delivering synchronized pulses of 0.11 and 10 petawatt for experiments conducted at the border between several fields of fundamental research like nuclear physics, photonics, plasma and solid-state physics, but also for applications